Hello friends, subscribe to our channel Effective Pharma and press the bell icon for the more updates.
We will going to discuss about what is IR spectroscopy and what is its principle. To identify which functional group or groups are present in a molecule or in a chemical compound, we use IR spectroscopy technique. To perform IR spectroscopy technique, we use a specific range of electromagnetic spectrum. See here diagram. That's we call as IR infrared radiations. IR radiations is made up of different range of wavelength, and these applications of IR radiations is known as IR spectroscopy. To identify which functional group are present in the sample, we make use of radiation. So since we apply IR radiations on the sample, we call this technique as IR spectroscopy. Now let's take a look on at principle of IR spectroscopy. Whatever sample we want to analyze, that could be in the solid, liquid, gas, we prepare the sample and put it in the IR spectrophotometer. IR spectrophotometer is the instrument that is used in the IR spectroscopy. So after we place the sample in the IR spectrophotometer, there is a source, there is a source present in the IR spectrophotometer, produces IR radiations, and these produce radiations of light of different wavelength travel in the form of energy, photons. So when these IR radiations fall on these samples, like let's say formaldehyde, so when these radiations fall on this molecule, the interatomic bonds in the molecule, that is bond between these atoms, molecule is known as interatomic bond. These interatomic bonds absorb the energy of IR radiations, and when these bonds absorb the energy, they start vibrating. These vibrations are of different types, stretching and bending. Before that, let's take about one other important points. As I mentioned earlier, IR is composed of range of different wavelength, and it is not necessary that sample molecule absorb light of every wavelength. They absorb light of specific wavelength. Suppose for example, let's take 100, 200 and 300 as a wavelength of different light present here. So suppose when the light fall on the sample, and this CH bond of the sample molecule between C and H, it absorbs the light of wavelength 300. Apart from that, the other remaining lights 100, 200 and 400 wavelength, it does not absorb them. That means these light transmit through the sample, because since no absorption occur, completely 100% transmittation happens. This transmitted light is detected by device. There is a device which is present inside the spectrophotometer. Detector detect transmitted light, and based upon spectrum is generated. That means graph is generated that we call as spectrum. On the y-axis spectrum, we have transmittance, which represents the transmitted light, and on the x-axis we have wavelength or wave numbers. 100, 200 light is not absorbed by the sample, and hence they are transmitted 100%. See, you can see this in graph. So if this transmitted light is not absorbed by the sample, this is 100% transmitted. You can see in this diagram, and the light that does not get absorbed shows straight lines here on this graph. So these lines here are transmitted lights which are not absorbed by the sample molecule. So this is our first point. After absorbing the energy, the interatomic bonds of the sample molecule start vibrating. Vibrations are of different types, such as stretching and the bending. Stretching means if we imagine the atoms of molecule where interatomic bonds behave like a spring, and in case of bending, they bends forward and backward. Stretching and bending are again further classified in different types. In the symmetric staging, in case of symmetric staging, the two different atoms that are associated with the center atoms, they stretch symmetrically. To imagine, we can think of bond like a spring, and atoms compress and decompress along with spring. In case of asymmetric stretching, the atoms are associated with the center atoms stretch asymmetrically. Stretch. Apart from that, bending is also classified into rocking, scissoring, wagging, and twisting. Now, there is another important point is here that it is not necessary that molecule absorb only the one specific type of wavelength. As we discussed that this CH bond in the formaldehyde absorb the light 300 wavelength and shows staging. But suppose if light 400 wavelength fall on this sample and then this bond shows bending, that means this bond can show different type of vibrations on different type of wavelength. It is not fixed that one type of bond will only absorb one type of wavelength and will have only one type of vibrations. So let's assume that this bond stretches on 300 wavelength and bends on 400 wavelength. So then we look at spectrum here. So here an x-axis 300 and 400 wavelength will see the peaks of absorption, because this light are absorbed by the sample molecule in the sample, and hence transmittance will be less, and the detector will detect less amount of transmitted light. So here, for example, on a 300 axis, we have seen only the 20% of transmit on y-axis, because 80% light was absorbed by the sample. Similarly, for 400 we see the 30% transmittance. After absorption, sample molecule vibrated. Now, as we discussed that a single molecule can show the multiple types of vibrations. So to calculate this number of vibrations, we have so we have a formula for calculating this. For linear molecule like CO2 is a linear molecule. So for linear molecule, formula is 3n minus 5, where the n is number of atom, and for non-linear molecule, formula is 3n minus 6. We can use this formula to calculate the number of vibration this molecule will shows. Next, we will discuss about the spectrum. There are two main important regions in the spectrum, as you can see in this graph: absorption region and the fingerprint region. In the absorption region contains individual peaks that we can easily identify, whereas in the fingerprint regions there are many multiple peaks and which are difficult to identify. But every component has a specific fingerprint region. By matching the fingerprint region with the spectrum library, we can identify that what component it could be. Apart from that, these individual peaks that are present in the absorption region, which are clearly distinguishable from each other, to see on what wavelength we have got the peaks. Like 300 we have this peak, and 400 like we have this peak. So by comparing this value for individual peaks against a reference list, we can identify which possible functional group could be present in the compound.